Hello, my name is Adam Kubas. I'm the director of the Institute of Physical Chemistry, Polish Academy of Sciences. And Dr. Richard Liu of Harvard University from US is with us. Hello, Richard. Richard is the winner of 2024 Dream Chemistry Award.
Yes.
The statue is with us. So, Richard, your dreams are closer to becoming true.
That's true.
How do you feel about it?
Well, this event has been tremendously energizing and exciting for me. First, even to be selected for the event, I think made me gain a lot of confidence that these dreams are worth pursuing. And then seeing all the other candidates and their dreams, all the other finalists, I mean, it was just a celebration of really diverse and creative ideas. It certainly gave me, dreams are like these living things. Sometimes they get weaker, sometimes they get stronger, they sleep, they breathe, etc. And I think this event was ultimate nourishment for my dreams. It certainly gave me a lot of encouragement.
Okay, so as we are both scientists, we know that science nowadays is dominated by short-term perspective. So acquiring grants, 3 years, 5 years grants, is, I would say, short perspective. How important it is to have such a dream, such a long-term perspective?
I think it's absolutely critical. And to be clear, I think the short-term motivations are also important. We get funded by taxpayers. We want to deliver things that will have immediate impact on society. But a lot of the bigger things that have happened in science, when they were done, we couldn't predict what the effect would be on society till 20, 30, 40 years later. I think we need to continue dreaming. And if you look at all the other awards out there, like you said, they're based on productivity, your publications in the last few years, right, where you went to school, things like that. This, as far as I know, is the only competition that rewards dreaming in the long term. And I think that's a great thing that we need to see more of everywhere.
Yeah, so this long-term perspective, as you said, is extremely important. I have seen in your talk today, that you are doing wonderful multi-component catalysis with multiple substrates coming together, creating final molecules. And I see this as a kind of a short-term goal to reach this long-term goal that you presented as your dream to replace these metals in catalysis. Mm-hmm. So what is your short-term goal? I would say a mid-term goal to reach your dream. What is your path?
Well, it's really hard to predict the timeline of how science will evolve, but I think the short-term goal, there are reactions that people dream of doing, or at least if we could make them happen, would make people's lives easier. Medicinal chemists, discovery chemists, other people who discover compounds. We make the tools that they can use, and that's a short-term kind of reward for us. The longer-term reward I really think of as generating the knowledge about how chemistry works. What are the rules that you use to create reactions? And those could be reactions that involve metals, or reactions that involve organic redox mediators, or involve, like as in my dream, organic molecules that act as metals. When you build that base of knowledge, then I think you will often see rewards many, many years in the future.
So how the society will benefit when your dream will be fulfilled? Okay. When we replace metals in catalysts, how the society will benefit?
To be very precise, I don't think that metals need to be replaced completely. Okay. There are situations where metals are perfectly apt. They do trillions of turnovers, or they can be used in a sustainable way. They can be recovered, etc. But when we discover new kinds of catalysts that are inspired by metals, we might actually be able to do new chemistry. We might be able to do some of the old chemistry a little bit better, safer, in cheaper ways, or with higher efficiencies. But we might also be able to do new reactions that currently we can't do with metals. But those new reactions are inspired by what metals can currently do and what we learn from metals, and then apply to organic molecules. So I think society will benefit in multiple ways. First, from the new molecules that we can make. They might end up being useful medicines or agrochemicals or fragrances or whatever society needs. But they can also benefit from the training of all these students and trainees who are learning how to develop new reactions, how to optimize reactions, do chemistry, think about chemistry. And often they'll go on to be academics, leaders all over the world, and make a difference as scientists.
You mentioned about younger scientists. I think it's the right moment in your career. Young people will look at you right now and look for inspirations, what will be your message to younger scientists, students, and researchers, younger researchers?
Yeah, it's such a funny thing because just maybe 5 or 10 years ago, I was a graduate student, an undergraduate student. I really don't feel super qualified to give advice, but I think one observation I've had during my time as a student is you really have to focus on what are your own strengths, and everyone has different strengths. And instead of focusing on the weaknesses and making those better, find what are your strengths and then put yourself in environments where you get to use those strengths. So if your strength is that you're great at discovering new reactions or something, you don't have to keep worrying about, oh, am I great at writing or am I great at, those things will come naturally as you do them. Put yourself in situations where someone needs you to discover a reaction. You can showcase your talent, showcase your skills. Always look for opportunities to apply what you're naturally good at or what you've trained to be good at to help other people and to help science.
So when you are creating, so you created your own group already. And you said something during your presentation about the selection of new PhD students, that you have to fight for them at some point. Can you say a bit more about this?
Yeah.
So how you attract younger students to your group?
Yeah, fight is a very dramatic, maybe a better way I could have put it is it's a matchmaking process.
Okay.
Students they're not agents for us, they're the main purpose of our job. And students want different things. Some of them want to become, like me, a professor or to do professional research. Others want to become teachers or work in industry or become lawyers or politicians. So first, it's about knowing what the student wants to do, if they know. They might not know. And second,
even at the PhD student level.
Yes, and you have to be then very honest about what your group is trying to create, what my group is trying to create, the culture that we want to have, the types of problems we want to pursue. And ultimately, it's completely the student's choice. We're not in the business of tricking students into joining our group. That's not good for anyone. We want students who are really dedicated to the mission of our group. And we know that in 5-10 years, a lot of the group's ideas will have come from the students, not from me. So what I'm most looking for is students that are a good fit for the mission of our group, and students that'll fit well with each other and make the best out of each other.
Wonderful. Yeah. Richard, it was wonderful to have you here. Once again, congratulations for receiving the Dream Chemistry Award, and thank you for
this
interview. Thank you.
Thank you.